As I was preparing for this talk, it occurred to me that many of the things I want to say today, I've actually already printed on t-shirts. And so the new subtitle for my talk is Been There, Learned That, Made the T-shirt. Firstly, a big thank you to my employer, CMD Solutions, not only for sponsoring community-run conferences like DevOpsDays, but for allowing me to come and participate here and learn from the DevOps community and share my thoughts with the DevOps community. I've been in IT for over 30 years, and there's always something more to learn. I've been totally thrilled by today's sessions in the sense of the emphasis on culture. It's 3 a.m., early Saturday morning, and the two of you, a developer and a sysadmin, are in at the office completing the change that you began Friday night. It's an upgrade to your core business system. So far, everything's gone according to the 300-line CAB-approved spreadsheet with step-by-step instructions. You're just waiting for the change program that does a transformation on the database to complete, and you just feel that it's been running a bit long. It's late and you're tired, but diligence dictates that you check your notes, and sure enough, this has been going for nearly 2 hours, and when you did the dry run, it was only 30 minutes in test. You're not alarmed yet. Everything on this system seems to be a bit different in production. But a cautious sense of curiosity is asserting itself, so you double-check the command you typed. The parameters are exactly the same as you intended them to be and what was run in test. So trying to figure out what's happened, you dig into the file system, and that's funny. The timestamp on that change program is 4 years ago? That can't be right. Quick trip via Vim to open it up and see what's going on, and you realise that the developer, the software vendor, has shipped you a change by reusing an old change program, not renaming the file, and giving no external indication of version. Sadly, this realisation does not surprise you. Looking into what's happening, you start to go through the SQL to see if you can understand what's going on, and you know database developer, but it looks like for the last 2 hours, it's been doing a row-by-row destructive update of every field of data that your company needs in order to continue to exist in production. Neither of you are DB admins. You call your colleague over to confer, and fortunately, you're both confident that the backups you took early Friday evening completed successfully. Unfortunately, you're both just as confident that nobody has ever performed a full restore of the database in production or even tried it in test. Time to escalate and call the vendor. Have I mentioned it's 3 a.m.? As time passes and repeated calls to the vendor go unanswered, not so your internal escalations. By 4 a.m, you're starting to accrue managers. The IT operations manager is there, as is the delivery operations, the application delivery manager. And they're both there, checking your progress while you panic. You're pretty certain that at first light, the CIO is coming in to get a situation report, give you some personal encouragement, and perhaps career advice. Now let me stop right there. Who here has already got a Linux console open on one monitor and seek.com.au on the other? Is anybody already rehearsing for the post-incident review exactly how you're going to hang this on the software vendor and their poor software practices? Or perhaps you're already thinking, that can't be a real story. Maybe you're thinking, that had never happened to us, our systems are better, we're smarter, we're not that stupid. I firmly believe that nobody comes to work to do a bad job. Nobody comes to work and think, how can I fail today? But, well, actually, let me check. Who comes to work each day to look ignorant or incompetent, intrusive, negative? We just don't do that. We want to do a good job. But what I want to look at today is DevOps through the lens of failure. Not just how do we cope with failure, but the fact that DevOps actually relies on failure. We to some extent, want failure because it makes us better. So I'm going to do that by looking at the 3 ways of DevOps. If you haven't heard of those, don't worry. You don't have to soak in the DevOps literature. I'll run you through them briefly. The first way is flow. I'm sure everybody knows that DevOps as a practice, as a culture, as a community came into existence to try and build the gap between, or in fact, in some companies, the chasm between developers and operation. After all, devs are these guys that say, it works on my machine, we're done, right? And their job, the reason developers exist, our job, the reason developers exist, is to create change. It doesn't matter whether it's a feature request or a bug fix, it all exists because you don't want it to be the same after it's been deployed, right? You're trying to create change. Sysadmins, operations, on the other hand, they're tasked with keeping everything up and running, reliable and stable, and change is the enemy. And as we heard this morning, all it takes is some experience in the past that went bad, and you're going to have more and more checks put into place. It's going to be harder and harder for the business to allow you to do what you have to do because you can't get a change window. And the more those changes back up, the bigger the change becomes as we load more and more stuff into it. And then this fear of change becomes a self-fulfilling prophecy because, guess what? There's so much change, something's bound to break. So DevOps is all about getting a fast flow of work from development into operations. And it's doing that at a smaller, repeatable, reliable way. But it's not just from dev to ops, it's from idea, from product management feature list, from crazy marketing scheme, through to actually creating business value, being used by customers. And so what we want to do is to be able to ease this process, remove friction. And there's various ways that we do this in DevOps. One of the fundamental ways is version control. If only that software vendor had used some version control. Interestingly enough, whether operations uses version control is a far greater predictor of being a high-performing organisation than whether development does. Keeping your configurations under versions, but version control is not just about controlling different versions, it's actually about managing failure. Because if worst comes to worst, and you can all try different things, whether you check out on feature branches or you develop on trunk, it's about being able to work from a common known set of code base and being able to experiment, but also wind back. You can go back and retrace your steps. So worst comes to worst, you can hit that ejector seat of git reset hard, and we're back to where we were. Whew. Better than a backup. Probably more synonymous with DevOps and continuous flow is the idea of a build pipeline, a CI/CD pipeline. In fact, it's kind of the icon of DevOps. You see these t-shirts, all the meetups you go to, that continuous loop of plan, code, build, test, deploy, operate, monitor, repeat. But I want to suggest to you that automating those processes is not the thing that creates the most flow, not the thing that reduces the friction the most. And it's counterintuitive. Actually, let me ask, who here has got some kind of IoT hooked up to their build pipeline or some sort of device, whether it's klaxons going off or a lava lamp turning on when you break the build, when someone breaks the build? A set of traffic lights, anybody? Papercut actually have a USB positionable foam rocket launcher that, through some equivalent of geocoding inside an office, coordinate coding, points to the developer's chair whose commit broke the build and fires rockets at them. I want to suggest to you that it's actually the ability to break the build that increases flow. Every time we put automated tests, compliance checks, vulnerability scanning into the pipeline and say, yes, don't just emit a warning, stop the build, you increase flow, even though it feels like you're slowing things down. The reason this is because when you're trying to remove waste from a process, many of you have probably heard of the connections between lean manufacturing and lean, trying to remove waste from processes, and agile development and DevOps. When you're trying to remove waste from a process, one of the things you do in a value stream mapping exercise is you look at the work that's come from the upstream workstation to you and what percentage it is complete and accurate. because incomplete work you can't work on, and inaccurate work just needs to be fixed, either by you or sent back, bottling up the process, or you pass it downstream as a further defect, and now it's even more expensive to fix. So from a systems view, the ability to, thank you for breaking the build. We have the ability to actually increase flow and fix problems where they have. This is the equivalent, if you've looked at the Toyota production system and lean theory, of them pulling that, what's called the andon cord, to stop manufacturing at that point if there's a problem, and fix the problem before it backs up with work in progress. Another thing that we do to create flow is to define our infrastructure as code. This is great. We heard before about the whole engineers just want to spend money for the sake of it, and they order a server and you wait for months. I've been on the other end of that request process. You wait for months, then it's got to be installed in a data center, racked, networked, commissioned, hardened, and the project, you know, the opportunity's gone. So we increase flow by infrastructure as code, but we also isolate the cost of error in that, the cost of failure. If you specified the wrong sized server, no negotiating with the vendor to try and get a credit and buy a different one and then start the procurement process again. You just change a parameter and redeploy. But this one's my favourite. There's absolutely no reason now for not testing on an exactly production equivalent environment. If the first time your code hits a production identical environment is production, you're actually testing in production. You're testing environment failures in production, or as I like to put it, you're running in production in your test environment. So we want our failures to occur earlier, shift left, every time you get a chance. The second way of DevOps is creating and amplifying feedback loops. We want to be able to get fast feedback signals. You ask any process control engineer, and the speed of your feedback loop is the speed at which you can adapt to error. So we want fast feedback. We've created our fast flow of work from dev to ops. Now we want to actually get information back from the operating environment, from running in production, back to development so that they can understand how the system really works, because we only think we understand how the systems that we develop works. And we're always refining our mental model of what's really happening. One of the well-known ways to do this is to have developers carry a pager rather than, hey, that's an operations problem. One of the reasons we do this is it brings the distance between what caused the failure, code that got in that is maybe causing an issue, and when you get to see the failure and remediate, much closer. We're tightening that feedback loop. At AWS, this is known as you build it, you run it. I seem to have lost one. One of the reasons that we want to measure everything, if you're going to get feedback, you want it to be information rich. At Etsy, I came across a great quote. If we have a religion at Etsy, it's the church of graphs. If it moves, we graph it. If it doesn't move, we graph it anyway in case it decides to make a run for it. What we need to do is create metrics at every level of the stack. At the business layer, we want to know abandoned shopping carts or time to, from registration to first transaction, or conversions from free accounts to premium accounts. We want to know how our applications are affecting our business. At the application layer, it's the usual things of execution paths or interim results or time for a database query. And the speeds and feeds guys in operations want CPU, memory, IOs. But a source of rich information that you may or may not be putting metrics on is your CI/CD pipeline. When did deploys happen? When did you start running that A/B test? If you provide an easy way to instrument code, and that's why StatsD exists at Etsy, take away any excuse. They've got APIs for just about every language whereby you can now instrument and measure your code with timers or counters or whatever else. And then it's there, if you've chosen your metrics well, to pick out whatever you need. But the real power is in centralizing that, and when you have a failure, being able to see what's going on. Oh, our sign-up rates dropped off by 40%. Coincidentally, perhaps, the database response times have started to climb and climb and climb just after we deployed that patch. So with information-rich signals, we use that ability to get feedback to actually deal with failure in a more intelligent way. Let's take a look again at automated testing. There was a great discussion that happened yesterday in the open spaces around shift-left testing. Many of you will have heard of the test pyramid popularised by Martin Fowler. The test pyramid basically says we want to do as much testing as we can at the bottom layer where it's fast feedback, quick to implement, gives us signals really quickly, and cheap because we can automate it very easily. As we move up the stack and get to service level testing, we need to call in other components. There's a bit more infrastructure involved. We can still write automated tests for that, but those tests take a lot more thought. And so we do less of those because the feedback takes longer. You've actually got to build the infrastructure, have it talk with other infrastructure. And then at the top layer, the human testers that have to actually, we used to do this the other way around. Everything used to happen with the top layer being the most testing. But the feedback is slow, and slow feedback is death. If we want to, and the whole thing about shift-left testing is great. If you find a test that's failing at the integration layer, and it maybe took an hour or two before you got that feedback, see if you can find a unit test that would have picked up what caused that integration test failure. Shift the test cases left, or in this case, down the bottom of the pyramid, so that you can actually get feedback sooner, cycle faster. And the whole reason we want to do this is the third way of DevOps, continual experimentation and learning. We want to be able to iterate really, really fast because that's what produces value quickly. That's what gets IT out of the way of a business of being a blocker or a cost and actually allows the business to move at the speed of business without IT being an impediment. You may have heard of the expression, out-experiment the competition. That actually means out-fail the competition, fail faster than they do, because the reason you run experiments is because you don't know the answer. You need to find out what fails. Ronnie Kahavi at Microsoft did a series of rigorous studies on A/B testing, hypothesis-driven development, and the idea was, let's take the feature list that product managers have, let's have them define clearly the metrics they think those features will improve, and let's run some A/B tests, and we'll do it very quickly with prototyping, and we'll only support Internet Explorer because it's only going inside Microsoft, and we'll just see if these hypotheses are true. 1/3 of the product features made absolutely no difference or marginal difference to the desired metrics. Money well not invested. But another third actually made those target metrics go down. They made the product worse. In that case, you're actually better off paying your developers to be on leave than actually make your product worse. So knowing what not to do is really important. So failure is really important. A lot of this stuff is counterintuitive, but the 2014, I think it was, State of DevOps report said that high performers deploy 30 times faster than low performers. Now that figure is now astronomically well out past 30. 30 times more often, but they experience half the change failure rate. Now do the maths with me. 30 times a half, 15. They're failing 15 times faster than low performers. Failure is good. We need to fail because it gives us information that we can act on. Now, no talk about failure would be complete without these guys, the Simian Army, Netflix Chaos Monkey. I've learned not to assume that everybody that comes to a conference like this is familiar with what some of us would think is common knowledge. So let me reintroduce to you Chaos Monkey, the way the world first learned about it in 2011. In April 2011, there was a major AWS outage on the US East Coast region of AWS where they lost an entire availability zone, an entire data center. Effectively, it was a failure that cascaded that made it effectively a loss. And big high-profile clients like Quora and Reddit suddenly disappeared off the internet. Massive outages. Conspicuous in their survival was Netflix. And conspiracy theories abound, and rumours started to circulate that perhaps Netflix were paying AWS, or because they were such a valuable customer, they'd come to some commercial arrangement to get preferential treatment if AWS resources should be scarce or something. And that's when the world learned about Chaos Monkey, because in 2009, 2 years earlier, they embarked on a re-architecting of their platform, because you know they started as DVD shipping service, right? They embarked on a re-architecting of their platform to be cloud native. And they wanted their developers to get used to the idea that the cloud is unreliable, and so you need to use design patterns that allow your software and services to be resilient in the face of underlying failure or underlying unreliability. So what they did was they taught them all these design patterns. They gave them pages and says, you know, we want you guys to be available if anything happens. And then without telling them, they turned on Chaos Monkey in production. Chaos Monkey is a service that randomly, regularly kills other services. There's a whole family of monkeys in the Simian army, but the one that was in question here was EC2 instances, compute instances. If randomly your server would just be killed, no graceful shutdown. And the theory is, and I'm glad we're doing a talk about it later, or might be if you vote, they only survived that failure because for 2 years in production they had been regularly failing all the time. The developers that heard the talks that they'd come to about resilience and all the rest of it and didn't apply the patterns soon learned to apply those patterns. And so we design for failure and then we deliberately break things to make it better. Now, can I ask, because everybody loves these stories and everybody thinks, yes, that's a great idea, is anyone actually deliberately killing things in production? Yeah. Oh, excellent. I'd love to have a chat later because it's one of those things that Oren's talk about how do you get this stuff through your business. You try selling the value proposition of that, particularly in stateful services. It's a very interesting conversation. But probably the most important time you want to be a learning organisation is the experiments that you didn't plan for. I love this one. This was from a recent DevOps Enterprise Summit. John Allspar, who I think is one of the great thought leaders of DevOps, said incidents are an unplanned investment in your company's survival. Think about that. Someone, whether it be the cruel hand of fate or a malicious actor, has taken out something in your environment and now it's costing your business money. You have no say over the timing of that investment and you have no say over the cost of that investment. The only say is how fast you can fix it. So the thing that you can really control in that situation is the ROI, the return on that investment. What are you going to learn from that incident that is actually going to make things better? When John was at Etsy, he popularised the idea of the blameless post-mortem. For me, this is a continuation of stuff that I've been reading about since I said I've been in IT for 30 years, since forever. There's a book written by Jerry Weinberg in 1971 called The Psychology of Computer Programming, which introduced to the world the idea of egoless programming and this contempt culture about meritocracy and all the rest of it, of how great I am, was bound up in my identity is my code. And he tried to talk people through the idea of, this is code that I just happened to write. We're all in this together. And really I see blameless postmortems as a continuation of that same thread of IT is a people business. And so we need to think about how do we make it safe? The idea of blameless postmortems is making it safe for people to tell what really happened without the temptation to cover up or clam up. Blameless postmortems, some of the things to be aware of, hindsight bias and the fundamental attribution error. I don't have time to dig into those today, but if you want to know more about that, read Dave McRaney's book, our keynote from the first day, on You Are Not So Smart. I will say, I will unpack finding a single root cause. If your post-incident reviews stop at the point of operator error, developer error, human error, anything in that category, that's just the point where you left off thinking. We actually need to get beyond that and understand the system's view of how did it make sense for the operator to do that thing at that time? Because they didn't come to work to do a bad job. More importantly, Is the goal of your PIR, your post-incident review, or any kind of debrief, whatever you call it in your business, to get to the action items? Yes, we want to prepare for a future where we are just as dumb tomorrow as we are today. We need to deploy countermeasures that protect ourselves from our future selves. So action items are really important, but it's the learning journey and the temptation under time pressure of a post-incident review when you've all got to get back to work is, yes, there's no point going over the history of what actually happened. Let's just get to the outcomes. You are wasting valuable gold if you do it that way. Because it's the telling of the story. Do we ever ask, why wasn't this incident far worse than it was? Was it just because Mary knew so much about this because she'd once worked on the system that it interfaced with? Are we telling the stories that allow us all to build a better model, not only of how our systems work, but how our complex systems fail, because they don't fail the way that we think that they do? And that brings me to a couple of terms that are in the DevOps literature that I just want to briefly introduce you to if you haven't read them. The first is safety culture and the second is psychological safety. Safety culture is prevalent in industries and environments where safe practices are actually a matter of life and death. Airline pilots, hospitals, emergency surgery, intensive care, heavy manufacturing. People not following process and safety protocols can cost life. And the old world view of safety processes was, we've defined these perfect processes. If you just do as we say, everyone will be safe. And so the question you ask after a human error incident in that kind of environment is, who's at fault? Who needs to be punished? Who caused the problem? Whereas Safety 2 view of the world looks at, nobody came to work to do a bad job today. What happened here that made this a sensible decision? What caused the problem? Are we maybe setting them conflicting goals? We want all your software to be 100% safe and secure with no security InfoSec threats, but get it out quick and ship another one next week. Is the system causing our problems? And so instead we ask, who got hurt? What are their needs? How do we fix this? The second one that really enables the blameless postmortems is psychological safety. Really, it's simply the belief that no one will be punished or humiliated for speaking up with ideas, questions, concerns, or mistakes. And Google, who do data on everything, had a project where they were trying to work out what separated high-performing teams from other teams at Google. And other teams at Google are still high-performing teams. They're just not at that other end of the bell curve that's just a little bit special and out there from everybody else. And they looked at every possible dimension they could. They came up with 5, but the gap between number 1 and number 2 was huge. The biggest differentiator, and it didn't matter how many PhDs were on the team or barely high school graduates, it didn't matter the mix of whether it was functional or cross-functional teams. The biggest differentiator was whether people felt safe suggesting ideas, challenging the status quo, and able to ask questions without appearing dumb. If you want a high-performing team, if you want an organisationally, a culture that allows you to learn, you need to be able to create a sense of it's safe to ask questions or admit mistakes. Which I wanted to go through that before I got to the point of when people fail. What happens if the failure, the incident that was unplanned by you but ended up costing a lot of money, was the direct result of one of your people? I started by asking if anyone comes to work to look ignorant, incompetent, intrusive, or negative. Amy Edmondson, who's done a lot of study of this at the Harvard Business Institute, says that we've actually been preparing and refining the skills that we use to avoid looking like this all our lives. Because if you don't want to look ignorant, don't ask questions. If you don't want to look incompetent, don't admit mistakes. If you don't want to appear intrusive, don't offer ideas. And if you don't want to come across as negative, don't ever challenge the status quo. You'll certainly avoid looking stupid. At this point, several of my former managers will be saying to me, that's great, but my boss holds me accountable. And their boss sets goals for them, and they hold them accountable, and that all trickles down to me. And what you're telling me is I should allow my people to stuff up, there should never be any consequences. That's all very well for you in La La Land, but I've got a business to run. The problem with that, as I said, the highest performing teams at Google actually felt psychologically safe. So the problem with that is it's actually counterfactual. It runs contrary to the evidence because the accountability to meet demanding goals is a false dichotomy when put in opposition with psychological safety. They're actually orthogonal. You plot them on two different axes. And the work that Amy Edmondson done, you know, the classic business types just do 4 graphs. I'll use some contempt culture here, please forgive me, because they can only cope with 4 possible quadrants. But it really does simplify things, right? We love that idea of just keeping it simple. If you're in a business where there is low psychological safety, you're afraid to speak up, but no one's really driving or measuring what you need to achieve, then you're in the apathy zone. This is your sort of low-performing bureaucracies where everyone's jockeying for position, but no one really cares about the outcome. It's all just about the internal politics and power. On the other hand, if you've loved coming to work because the people you work with are great and no one's going to judge you, but you're not ever really being stretched, this is the comfort zone. And this might be perfectly okay. Perhaps you're running a family cafe that sells the best chicken schnitzel in the world, and you're never going to take over the world and start a chain, but you're making a reliable income for grandma and everybody, and it's just fun to come to work. But you're not going to set the world on fire. The one that should worry us the most is this, and I have worked for several of these companies, the anxiety zone, where it is not safe from your career perspective to speak up. So you start developing habits of how you can tell the story factually, but just with a bit of a spin on it so that you're the hero or so that it wasn't you that stuffed up. Where do we want to be? Of course we want to be in this area where we can actually feel safe to ask questions, to look dumb, but at the same time reach goals that are set for us. I said the literature doesn't support the false dichotomy. You ask any airline pilot who's in charge of that international flight whether they want to be in the comfort zone and not held accountable, or the apathy zone, not held accountable for their actions. They got into that profession because they're a responsible person. If you set demanding goals and provide psychological safety, we all get to learn in the pursuit of high-performing outcomes. They're all the t-shirts I've thought of so far. I'd love to continue the conversation. If you would like to talk more about failure, I know there's a chaos engineering one, but if anyone thinks there's a gap based on the talk that I've just presented, please talk to the guys, get an extra post-it note written up, and I'd be happy to be part of that. Thanks very much.